So in this video we're going to be discussing circular motion. We'll investigate circular motion, find out the speed and acceleration of anything that is spinning or going round in a circular path. We'll figure out the forces involved in circular motion, identifying and even calculating. So, quick question. If you were on a merry-go-round and you are going around in a circular path like this, but let's say you fell off, how would you land on the floor? Would you go in a curved way? Would you go straight? Would you fall straight back down? Would you go out? What do you think would happen? You'll actually find at this particular point you're facing this way. You would continue off in a straight line, in a straight path, all the way to the end. You will not curve, you will not go outwards, you will go in a straight path. So that's an important thing to remember. We'll do that in a little bit more detail very soon. A few words that we're going to use: vector, velocity, acceleration, degrees, radius, circumference, and tangent. You know all of these, we've discussed all of this already. Radius and circumference and tangent. Let's see what that means. So if I have a circle, no idea what that is. I have a radius, that's what it is, my pen's not working. I have a radius, and then you would have a circumference, which is the whole thing around. This is my circumference, see, all the way around, all the way. Tangent is a line that's touching a circle. This is all from math. You would have done this before in math. Another key point actually that I didn't mention was diameter. You might be given a diameter, d. The radius is half of the diameter. So just remember that for later. Perhaps it will be useful for us. So these cars, in this case, are going around a curve. They're going around this way. They're traveling at a constant speed of 120 kilometers an hour. Are they accelerating? The speed is not changing. So are they accelerating? You might be tempted to say no, but remember, acceleration is a vector. It has a size and a direction. So it might not have a magnitude, but it does have a direction. So yes, they are accelerating. The velocity is changing because the direction is changing, which means it is accelerating. It's a change in velocity over time, so there is an acceleration. So if you're changing direction, you are always accelerating. And you'll find the acceleration is facing towards the center of the path. Here is a circular motion, and there is my V going all the way around in a straight line, but it's getting pulled into the center of the circle. So anything that travels around a circle or a circular type path is a vector, and it is always accelerating. The speed might be constant, but the direction is constantly changing. So then is there acceleration. The force that brings it down is called, generally speaking, a centripetal force. It could be friction, gravity, it could be anything, whatever it is pulling to the center, it is the centripetal, center-seeking force. Tangential speed, as I drew earlier, is just a line that's going like that in a straight direction, touching the edge of the circle. Acceleration is towards the center, force towards the center, but the speed is going in a straight line. So if you have to fall off, you will just keep going in a straight path. Here are some examples. A ball tied to a string, spinning around. A child on a merry-go-round. A car driving on a curve. Earth or the moon orbiting the sun on Earth. Things like this. So in a yo-yo, what is the thing that's pushing it down? You might say gravity, but then what about when it's on this side? What's pushing it? What is the thing that's bringing it to the center? There is something that's pulling this yo-yo to the center. Of course, there is a string, so in this case, tension is the centripetal force. Tension is the center-seeking force in this case. We have a car turning. Of course, the wheels are on the road, so there must be friction stopping it. If there was no friction, the car will slide off and keep going straight. I've just answered that question. What would happen if there's no friction? It will slide off and keep going straight. Exactly. You will just slide off the track. So you need friction to turn in a car. What force makes the satellite come to Earth? What is this? We of course know this must be gravity force. That's stopping the satellite from exiting and going away in a different direction. Gravity is bringing it in. So if you want to define the tangential speed, well, we know it's distance divided by time. And if it's a circle, we will do the circumference divided by time. And if you know a bit of math, you know the circumference will be 2 pi r divided by time, or pi d. But we will use v equals 2 pi r divided by time. This is the first formula you will need. This will help you find the speed. A student gets on a ride at an amusement park, and the ride travels through a circle with a radius of this, and it makes one turn every this much second. Find the speed. So v is 2 pi r over t. I have the radius, I have my r, I have my seconds. The time must be seconds, by the way. If you said in minutes, you have to get it into seconds, multiply by 60. If you see hours, you multiply by 60 twice. But in this case, 5.8. So we go 2 pi multiplied by the radius of 6.5 divided by the time, which was 5.8, and you'll get your answer of 7.04 meters per second. Speed is measured, of course, in meters per second. Car drives around a circular track at the speed. It has a diameter. Find the time to make one complete turn. Now we need to find time, but I have a diameter. That's not good. The radius, I know, is half of the diameter. I mentioned that earlier. So my radius will just be 10 meters. Now I can use that in my formula. I have my v is 2 pi r over t. I can put my numbers in. 2 pi 10 divided by t. And you can do shift calc, or you can rearrange the formula. You can swap these two around, and you will get t equals 2 pi r over 13, and your final answer will become 4.83 seconds. Great. You can also find the acceleration. You can do the acceleration being v squared over r, v squared over the radius. That will help us calculate the acceleration. If you remember, v is 2 pi r over t, what you can do is you can square all of this. So 2 squared will be 4, pi squared will be pi squared, r squared will be r squared, but I'm dividing by r, so that will cancel the square. Actually, this r will cancel with the little square that I would have had. It'll be gone. There would have been an r over here, but this cancels with this r squared, leaving me with just r above. And divided by t squared, because I have to square everything. You don't need to know how it comes about. You just need to know that you have acceleration equals v squared over r, or you can say 4 pi squared r over t squared. Both ways. If you want to make life easier for yourself, calculate v, then put it into the formula. If you hate this, just do that. That's nice and easy. I would prefer to do that myself anyway, rather than a big crazy formula like this. 2 pi r over t, solve it, and then do v squared over r. We will do some practice questions soon. If there is an acceleration, of course, there is an imbalanced force causing it. So there is an inward force, we call it centripetal force, of course, Newton's second law. F equals ma, which is what we're going to discuss soon. If there was nothing stopping the ball, it will just keep going straight. Even if the car turned, the ball will continue straight. This is the point that I mentioned earlier on. So you must know that in this case, there is this block stopping the ball from going. So it must be applying a force on the ball to stop it from going. Okay? If you cut the string, look what happens. It's going to keep going straight. I know I've shown you many examples of this, but this is a very important idea, important concept in this circular motion. Okay, so passengers in the car, you're driving, car turns to the right. If it's going to the right, you'll feel that you're getting pushed to the left because you're going to be trying to be going in a straight path, but the side of the car is stopping you. So that's why even though you're turning to the right, it feels like you're going to the left of the car because your body was trying to go straight, but the car starts to block you. That is the centripetal force. So, as I said, Newton's second law, F equals ma. Instead of a, I can just put v squared over r. So F equals m v squared over r. That will help me calculate the force. You could calculate a first, and then you could substitute that into the formula if you wanted to. There's many ways to solve the same problem. Okay, so here is an example. Mr. Philip decides to go drifting in his 900 kilogram race car, that is a mass. He wants to show off by doing a 360 degree turn in a time of 2.4 seconds. If the diameter is 1.8, find the velocity. I do not like diameters, I want the radius, so I will have to do a half of the diameter. A half of 1.8 is 0.9. Half of 18 is 9, so that'll be 0.9 meters. There we go, that's my radius. I want to find my velocity. So for my velocity, I can do V equals the circumference, is a circle, 2 pi r over t. To be honest, you probably could have kept the diameter in pi d. Doesn't matter. We're using the formula. 2 pi r over d. So what am I going to do? I'm going to write 2 multiplied by pi in my calculator at the very bottom, multiplied by r, which is 0.9. And I'm going to divide all of this. I'm going to divide all of this by the time, which I know is 2.4. So let's quickly do that right now. 2 multiplied by pi multiplied by 0.9, and I'm going to then divide that by 2.4, and I should hopefully get 2.36. I'm going to round the 5 up to a 6, and that is my velocity, so meters per second. Nice. And then you need to find the acceleration, no problem. A equals v squared over r. So I've already found the v, so I'm just going to do 2.36, and I'm going to square it. I'm going to divide that by my radius, which I know is 0.9, and I'm going to put that into my calculator now. I'm going to do 2.36 squared divided by 0.9, and I should get 6.18, so I'll round that to 6.2 meters per second squared. Acceleration. F equals ma. F equals m. I did say v squared over r, we've already done that over here, so I can just keep that there. So F equals ma. Mass 900 multiplied by my a, which is 6.2, and I'm going to put that into my calculator now. So I've already got the previous number, so I'm going to multiply this by 900, and I should get a force of 5569.6. There's a point here. 0.6 newtons. And that's it. Done. Easy peasy.